Hello, somebody. Hello, wherever place you are. I'm David Kyle, the owner of the channel, the YouTube channel, the Teacher Kyle Explains, especially containing chemistry and some physics or principles in it. Now, do me one favor. Make sure you like, you share, but more and more, make sure you subscribe to my YouTube channel. Teacher Kyle Explains. It contains a lot of things, especially that are meant for our learners in school. Now, without much ado, let's go directly into our class. Thank you. Wow, thank you so much. In the last class, we had looked at what we call classification. We said that it's a grouping, mixture, two or more substances mixed together. Now, methods of separation, we looked at what we call the use of a magnet. We looked at sublimation. We also looked at the applications of sublimation. We looked at decantation and filtration. And we also looked at what we call the residue. We also looked at what we call the filtrate and all these ones here. We tackled it. Now, if you had not gotten this, I want to urge you so that you may go back to our class, the previous class, so that you may get whatever we discussed. Now, today I want us we continue with what we call crystallization. Now, we have what we call copper 2 sulfate. Copper 2 sulfate is a compound. This compound here contains there are three elements. There is copper, there is sulfur, and there is oxygen. Now, this one here, we are able to extract this copper 2 sulfate from its own solution using a method what we call crystallization. I will tell you what crystallization is. But before that one, now, if you take this copper 2 sulfate, if you take this copper 2 sulfate and you put it into a conical flask, for example, or into a beaker, and you put it here, then you pour water into it, so that maybe the amount of water will be 10 ml. Then you continue putting a lot of copper 2 sulfate into it. It will reach a point where now there will be no more solute being now dissolved by this water here. And that means that it has reached the extreme point. It has reached the extreme point in which it can never be taken again. Now, this kind of solution here that has been brought out or has been produced is what we call a saturated solution. And now, what is a saturated solution? And therefore, we are saying that a saturated solution, therefore, is a solution which cannot take any more solute at any given temperature. It cannot take more solute at any given temperature. Now, take a good example when you are taking a lot of sugar. For example, you are given tea to put sugar. So the more you continue putting a lot of sugar, that sugar, it is not all of it which will dissolve. Some of it will remain at the bottom of that container. It's because now it has reached the optimal point in which it needs to dissolve, and therefore we call it what we call a saturated solution. Now, during the crystallization process, we have what we call the glass rod. The glass rod is usually dipped. The moment you dip the glass rod, you lift it into the atmosphere. The reason as to why we dip it there and we lift into the atmosphere or into the air is to confirm whether the crystals have been formed. The crystals have been formed. During the process of evaporation, it is encouraged that evaporations need to be very slow. Why? For you to obtain crystals of larger size, you need to do what you call evaporation, but at a slower rate. So that means if you do evaporation at a faster rate, you end up getting a powder. But if you do it very slowly, you get something which is very large. In fact, who doesn't love things that are large? I also love, and that is why I love big vehicles. Now, let's continue. Now, whatever will be obtained during the process of crystallization is what we call a crystal. Now, teacher, what is a crystal? A crystal here now, a crystal, these are solids that have got a regular shape, and also they have a fixed amount of water in it. Very nice. Now, the process of obtaining crystals from a saturated solution is what we call what, my student? Is what we call crystallization. So a process of obtaining crystals from a saturated solution is what we call crystallization. Okay. Now, let me take you back again. A saturated solution is a solution that cannot take any more solid at any given temperature. It cannot dissolve. In other words, it becomes very hard for it to dissolve. Why do you think the glass rod needs to be dipped? It's because you need to confirm whether the crystals have been formed. Evaporations need to be taken very slowly so that you may obtain particles of larger size. The crystal, these are solids that have got a regular shape. Crystallization is that process of obtaining crystals from a saturated solution. Very nice, very nice, very nice. Now, this process here of crystallization is not applicable in the class alone. We also apply it also in other things. For example, if you want to extract sugar from the sugar cane, you use crystallization. If you want to extract herbal medicines from the plants, use crystallization. If you also want to extract salt from salty water, we also use what we call the crystallization. It is a process which is so nice for you to understand. Teacher, where is the diagram? I want to show you a simple diagram which you need to get here. Now, look here. This diagram here, as you can see, there is a water bath. This is a copper 2 sulfate solution. So the moment you do the mixing, it will reach a point where it cannot be dissolved. And what is the name given to that one? It is what we call a saturated solution. If you continue heating, you will now see that water will be driven away and you will remain with copper 2 sulfate. And this one here, what is the purpose of the glass rod? Is for you to confirm whether those crystals have been formed. Now, there is what we call the simple distillation. Very nice. Simple distillation is one of the methods of separation, of separating a solid liquid mixes, especially the soluble ones. Especially the soluble means a solute, that solid itself as dissolved in a liquid. Now, there is what we call a distillate. A distillate is a liquid that is obtained during the process of simple distillation. We also have what we call the cold water. Now, I want my camera person to look here. Now, this salt solution here, that means there is salt, then there is water. Very nice. So this salt, we want to obtain salt. At the same time, we don't want to remove water and get it into the atmosphere. We want to have the two of them with us, and therefore the moment this apparatus A, the moment you hit it, you will see that water will be driven, and now there is a delivery tube which helps to transfer or to transport that water vapor into container, into apparatus B. This apparatus B, we will have a colorless liquid formed. But down it, there is what you call the cold water. This one here is cold water. This is cold water. This cold water, its purpose is to condense the water vapor. Now, the delivery tube is for it to transfer or to transport the water vapor from apparatus A to apparatus B. Very nice. Now, this process here may not be that more efficient, and that's why we need to develop what we call a Liebig condenser. The purpose of a Liebig condenser is to increase the efficiency of the cooling and the efficiency of the cooling during the simple distillation. Now, look here. This is what you need to see. There is what you call water out, and there is what you call water in. The water that gets out here is hot water. Hot water. The water that comes in here is the cold water. That is what you need to understand and know in that case. So understand what crystallization is, understand what simple distillation is, and what are some of the applications of all these ones here. I will show you as the time goes by. Thank you so much. Thank you so much. Now, let's continue with another class. Thank you so much. If you enjoyed today's class, and I do believe that you got a lot, you enjoyed. Have you subscribed to my YouTube channel? Please, if not, do it once again. If you cannot do that, you won't see me. Thank you.